In this video, we'll start taking a look at PgAdmin, which is the GUI that we use to manage our Postgres instance. We'll take a look at how we can define our tables for Postgres. We'll take a look at how we can create entries in our database, as well as how to modify and delete them as well. So go ahead and search under your applications for PgAdmin. And you'll see that once it pops up for the first time, it's going to ask you to set the master password for PgAdmin. And it's important to understand that this password is for the PgAdmin GUI. It has nothing to do with the password that you created during the Postgres installation. This is strictly for PgAdmin itself. And the reason it asks for a password is that ultimately we can store our passwords for connecting to our different Postgres instances within PgAdmin so that we don't have to enter it every time we want to connect to our database. And so that's why we have to create a master password so that we could store all of the individual passwords for all of our Postgres instances. So I'm just going to create a random password in this case. And keep in mind, it does not have to match the password that was created for your Postgres instance. These two have nothing to do with one another. Now, the first thing that we want to do is specify the connection details for connecting to our Postgres instance. And what's nice about PgAdmin is that it'll remember all of the servers that we've ever connected to so that we don't have to manually input this information every time we log in. Now, PgAdmin has done a little bit of the work for us automatically. So if you see under the server section, this is where we define our individual Postgres instances. Just hit the little drop-down arrow, and you'll see that there was a server called Postgres QL13 already created for us. So by default, when you install Postgres, we know that we're going to have a local Postgres instance running on our local machine. So it's going to automatically set up the connection details for that instance. The only thing you have to provide is the password for connecting to that instance. And so now we want to pass in the password for the Postgres user for the Postgres instance. And this password isn't the password that we just created a few seconds ago. This password is the password for Postgres itself. So this is the one we created during the installation process. So go ahead and put that in there. And then you can choose to save this password so that you don't have to re-enter it. I'm just going to skip that for now. And so now it's taken that password and it's now connected to our local Postgres instance. And so you'll see a little bit of information about things like, what's the sessions, what are the transactions per second. So you'll see a lot of nice little pretty charts. However, I want to make sure that you guys actually understand how to define a new server instance. So what we're going to do is we're actually going to create this from scratch. So I'm just going to select this. We're going to select remove server. And we're going to do this straight from scratch. So I'll do create server. Let's give this a name. I'm going to call this my local Postgres instance, because that's what it is, local Postgres. Then we have to specify the connection details. So here we give the IP address that the Postgres instance runs on. Because this is running on our local machine, we can just say localhost. However, if this was running within AWS or some cloud provider, that cloud provider would provide you an IP address or even a domain name to connect to, and that's what you would specify here in this case. But since we're connecting to our local machine, we just say localhost. Then here we give the Postgres password. Right when we did the installation for Postgres, we used the default port, so that's why we could just leave this as 5432. And then as I mentioned, when we connect to Postgres, we always have to give it the name of a database to connect to. We always have to provide the name of a database to connect to. Since this is a fresh installation, the only database that's going to be there is going to be a database named Postgres, so it's going to connect to that by default. Then we have to give the username and password. And we haven't created a user yet, so there's always one default user. This is the super user, and the username for that user is always Postgres. A little confusing because the database name is Postgres, the name of the actual DBMS is Postgres, and then our username is also Postgres. So try not to get all three of those things confused. Then we could save in our password. So this is where we put in our Postgres password. And then if you want to save this for future so that you don't have to enter it every time, you can go ahead and do that. At that point, hit save. And then you can see that once again, we created this from scratch. Now within PgAdmin, there's going to be a lot of menus, a lot of things that you see, and you may be a little overwhelmed, but I want you to keep in mind that a majority of the stuff we won't really even care about. Right? So when you focus on just the things that we care about, you'll see that there aren't many things involved when it comes to PgAdmin. And so like I said, within a Postgres installation, right, we're going to have individual databases, right? So we can create a separate database for each of our applications. So under our server, right, you'll see a section called databases. So this looks a little interesting. Let's click this. All right, and then if we drop this down or expand this, you'll see that we have our one default Postgres instance that was created for us during the installation process. Now, we're not going to touch this. We're just going to leave this there. But let's create our own Postgres instance. So right-click on Databases, hit Create, and then Database. And then here we just want to give the database a name. I'm going to call this, I usually just name it after my application name. So since this project is called FastAPI, I'm just going to call this my FastAPI database. And you'll see that there's a couple of other windows. We won't touch any of these. However, go to the last section right here where it says SQL. All right, and as I mentioned before, SQL is the language that we use to actually talk to Postgres. And since this GUI is here to manage Postgres, it's going to make our life a little bit easier. But at the end of the day, it's just passing in SQL statements. And so because we created a database through the GUI, it's kind of abstracting a lot of the SQL away from us. However, what's nice about PgAdmin is it's going to give you the underlying SQL that's used to actually create this database. So we could see that it's just a command that says create database, and then the name of the database we gave it. Here it's just specifying the owner, the encoding, and the connection limit. Technically, we could remove all of these lines and just take the semicolon and just put it right here. And then we could just do create database fast API, and that's how you do it through the command line. I think it's just nice and helpful that it provides this for us. However, ultimately, we won't need to do that because we do have PgAdmin, so we can do it all through the GUI. And if you guys are worried that we're not going to cover SQL, believe me, we will. But I just want to make sure we start off by taking a look at the GUI, learning it the easy way. Then we'll learn how to do it the harder and proper way. But once we got this set up, go ahead and hit save. And you'll see that we have our new database. Right now there's an X, but as soon as you click on it, it's going to turn yellow, which means that we have now successfully connected to this database. And then under this database, you're going to see a lot of different options. And like I said, we're not going to touch most of these. Instead, the only thing that we want to focus on is under schemas. So under schemas, and then under public, and I'm going to move this over for you guys, you'll see that there's one important section called tables. So this is where we actually create and define our tables. So right-click this. And actually, if we hit the dropdown, you can see there's no tables, but that's to be expected because this is a brand new database. And let's go ahead and create our first table. So we'll do right-click, create, and then table. And then let's give this our table a name. So let's say we're sticking with the whole e-commerce example. So we're going to create a table called products. So this table represents the different products that we're going to sell. Don't worry about any of these other fields. It says the owner is Postgres because we're logged in as the Postgres user. However, if we logged in as a separate user, then you would see the owner get updated accordingly. If we go into the column section, this is where we define our column. So this is where we're defining what is referred to as the schema of the database. So to add a new column, just hit the plus icon. And so now the first thing that we need to do is let's figure out what attributes does a product need. And a product is going to need a name. So let's give it a name. And so we'll call this column name because it represents the name of a product. All right, then we have to give it the data type. As I mentioned, there's going to be different data types that closely resemble or match the data types of a programming language. So a name is going to be, a certain amount of text, right? So we need whatever data type represents text. And so we've got a couple, right? We do have text, and then we also have varying character or character varying. This is the one I'm going to ultimately use. So we're going to select character varying. And if you actually want to see the difference between these, I recommend you go online, search for Postgres data types. Right? And then it's usually chapter 8 of the documentation. You can select this, and then this is going to give you a breakdown of the different data types. And it's going to break it down based off of, numeric types. We've got date time, Booleans, enumerated. We've got, if you want to represent IP addresses, we've got a data type for that. So there's a ton of different data types. Definitely take a quick read over all of these. However, we're just going to stick to the basics. So if you don't want to go through all of that, then we'll stick to just the core fundamentals for now. So anytime we're working with text, we're going to use character varying. And then as I mentioned, we've got a couple of options. So we've got the not null. And so right now it's set to no, which means that technically we can leave this entry blank. So we can create a brand new product with no name at all. And then Postgres is going to put in a value of null if we do that. But if we think about our application, right, would we really want to be able to create a product without a name? Doesn't really make sense. So I think we should set this to be yes, so that it actually throws an error if we try to do that. And you'll see a flag for a primary key. So we get to specify which column is ultimately our primary key. I don't think the name of a product should be a good primary key. We need the primary key to be a column that really emphasizes what makes each entry unique. And I don't think the name actually does that. So we're going to leave that set to no for now. And we're going to add in a new column. All right. And this time we'll add in, let's say, the price. And so now we have to specify a data type. So for numeric data types, we have an integer, which is going to be whole numbers, which probably isn't a good data type for prices because we need decimals. We do have numeric, and there's a couple of other ones. So if we go back to our documentation, hit numeric types, right? We've got numeric. So this allows us to specify also decimals as well versus integers. And then we also have floating point types as well. Either one of these can be used. They operate a little bit differently, but both of them will work. But since I want to keep things simple and I don't want to confuse you guys too much, I'm just going to use an integer to define a price. And I know technically there's no application that would ever use an integer to represent price, but I want to keep this simple. And I actually want to show you guys something unique. So you see that there's a couple of different types of integers. We have, first of all, a plain old integer. We've got a small int, and then we've got a big int. So what is the difference between all of those? Well, it's the number of bits that we have. So a small int has the fewest number of bits, which means that the maximum number we can go to is going to be a lot smaller versus a traditional integer. And then if we need to go up to a really high value, we're going to use big int, which is going to have the most number of bits. Right? And if you want a good explanation, just search for what is the difference between big int versus int. Right? And so we can see here, the difference between them is you can see the minimum value and you can see the maximum value. And so I think that's what, minus 2 billion to 2 billion. So we get it in the negative and the positive direction versus a big int, which is negative 9 to 9 billion. So you got to figure out what's the best fit for you. If you don't think you'll even hit 2 billion, then there's no reason to go to a big int. So I'm just going to leave this as a plain integer. We could definitely get away with the small integer, but let's not worry about that. I don't think we're ever going to have a product that's going to be $2 billion, but that's fine. All right, and then once again, we have the not null option. So it doesn't make sense to create a product that doesn't have a price. So let's make sure that's not nullable. And then the length and the precision, this is for floating points. So you can say like how many decimals do you want to support it for? For an integer though, it shouldn't matter. And it looks like I didn't properly select this. We'll do integer. All right, and then the last thing that we need is each product should have a unique ID. Right, and like I said, a lot of our tables are going to have an ID column. So here we're going to create a column called ID. And so what kind of data type should we use for this? Well, I think what makes sense is an integer, right? An ID is just going to be some random number. So we could use int, big int, or small int. And so let's just say we'll use an integer. I'm going to search for integer. However, I don't actually want to leave it like this. I did mention in one of the previous lectures that most databases support the ability to automatically generate a ID for you. So I don't want to have to be the one responsible for creating an ID and then putting that information into Postgres. I want to just provide the name and the price, and I want Postgres to generate a unique and random ID for that product. So how do we do that? Well, it's pretty easy. There's a data type called serial. And so a serial is just a regular integer. However, it automatically creates a random number. And it's actually not a random number. What it does is the first product we create will get a value of 1. The second one will get a value of 2. And it'll just increment by 1 for each product we add. So it's going to ensure that every single product we create gets a unique integer value for the ID column. And like I said, we do have small ints, big ints, and regular integers. This is the same thing, but it's just auto-incrementing for those 3 kinds. So I'm just going to say it's going to be a regular integer that increments by 1 automatically. And then this is going to be what's going to be the primary key, right? We know that the ID has to be unique. I think that makes sense to make it the primary key. And I think for now, this is a good enough starting point to learn about SQL and Postgres in general. So let's save this. And we have then successfully created our first table. And so under tables, you'll now see our products table. So let's start playing with this products table. Let's create entries. Let's delete entries. Let's really start to have fun with it. So right click on it. and select View, Edit Data. And then you can really select any one of these. If you select all rows, what it's going to do is it's going to fetch every single entry that we have in the database and show it to you. We don't have anything in the database, so it doesn't really matter. If you select first 100 rows, it's going to grab the first 100 rows in the database. And if you select last 100 rows, it's going to grab the last 100. Now, if this was a production server or something like that, we might have millions of entries. So you may not want to do all rows and then just get flooded with all of this data. So you may want to select one of these or filter out the rows based off of some criteria. But we have no actual data on it, so I'm just going to select all rows. And you'll see that within PgAdmin, we have these different tabs. So it opened up a new tab, and you see that there's like a little pop-up window. So if you can pause it and rewind, it says that it actually ran a query. And so what it did is it ran a query to retrieve all the rows, because that's what I selected, right? I selected, get me all of the rows by selecting all rows. And if you look at this query editor right here, this is the actual underlying SQL that it ran. So it ran select star from my products table, order by ID in an ascending fashion. So it's going to grab the first product with the lowest ID number and the next product with the second lowest ID number, and it's going to keep incrementing up. We've got nothing in our database, so it didn't return anything, but I think it's cool that it does show us the underlying SQL. Now, like I said, we don't have anything in our database at the moment, so let's go ahead and create our first entry. And so I'm going to select this column, and I'm just going to give it a name. So this is going to be, let's say, a TV. And then let's give it a price. I'll say this is $200. And then the ID, this is going to be automatically generated, so we don't need to provide a value. And so at this point, you may be thinking, well, it looks like we created an entry, right? We have our TV price of 200. Well, not exactly. To actually store this data in the database, right now we're just proposing changes. We have to select this button right here. So if you hover over this, this says Save Data Changes. So when you select this, this is actually going to push this data into the database. So let's do that. You can see that the data was saved successfully, and now it's actually in here in the database. So let's create a new entry. I'll say this is a DVD player. I don't know if anyone uses these anymore. And then let's give this a price. I'll say this is $80. And then we can just keep adding as many as we want. So let's add in a remote. This is going to be $10. All right, and you'll see that anything that's kind of bolded, so you notice how TV isn't as bolded as DVD and remote. So bolded means we haven't actually pushed it out to the database. It's just proposed changes. So we can push out both of these at the same time by pressing this again. So we push that, and then you can see that they got pushed out. And take a look at the ID column, right? The first item got an ID of 1, the second one got an ID of 2, and then 3, and it's just going to keep incrementing. Now let's have a little fun. Let's create a new item. This time let's make it a microphone or something. And let's leave this price column blank, and let's see what happens. So now if I press this, take a look at this error, null value in column price. So we left this value empty. So Postgres interpreted as null, but we set the column to be not null. So we told Postgres to do a check and say, hey, listen, if we ever don't provide a value, we want you to throw an error. So this is forcing us to provide a value for this, because creating a product without a price just doesn't seem to make sense. So let's give this a price. Save that. And so now that worked. And then this time, let's try creating a product with a price, but no name this time, right? So what do you expect to happen? Well, since we set the column to be not null, it's going to throw an error, or it should, hopefully. And look at that, null value in column name. So once again, it's not going to be supported, and it's going to throw an error. So let's just give it a name. Let's say this is a car, the world's cheapest car. Hit OK, save that. That's been successfully added. All right, so now that we've kind of played around with it a little bit, let's make this a little bit more interesting. And let's add in a brand new column to our products table. So right click on the products table right here and select properties. Then under columns, we're going to add in a brand new column. So we're just going to follow the same steps. And this column is going to represent if an item is on sale. So I'm going to call this is_bool. Sorry, not is_bool. It's going to be is_sale. And it's going to be a simple Boolean as the data type, because it's either going to be set to true, which means the item is on sale, or false, that the item is not on sale. So we'll do Boolean. And then everything else we're just going to leave by default. So for not null, we're going to leave this to be no. So we are going to allow the user to input a value of null in this case. However, what we're going to do is we're going to add in an extra constraint, I guess. Actually, we're going to set a default value. So if the user does not provide a value for is_sale, we're going to give it a default value and say that by default, if a product doesn't receive a property for is sale, it's going to be set to false. So it's not going to be on sale. So let's hit save. All right. And then right now you don't see a new column, but that's because you don't see the new is on sale column, but that's just because we need to refresh this page. So let's go under object. I think we could do it here. I think it should be a refresh. I didn't do anything. So I think we're just going to do the same thing as we did before. There should be a way to refresh this, but it looks like if I just press it here, it doesn't do anything. So instead, I'm just going to do a view, edit data, all rows again. It's going to open up a brand new tab. And now we can see the is_sale column here. And what's awesome about this is that because I provided a default value, it went to all of the other items in my database that were created before this column was created, and it provided a value of false because I said, listen, if the value is null or if we didn't provide that data, go ahead and put in the default value of false. And so now if I create a brand new item, and I'll say this is for a pencil, and the pencil is probably only $2. Now, since this can be set to null, I'm going to just leave that blank. And now if I save this, take a look at this. It gets the default value that we provided. So you'll see that for a lot of your columns, you're going to want to provide default values if you expect it to be frequently inputted without a value and you want it to receive a default value. And now, once again, I'm going to actually create a brand new column once more. And then we'll go to properties. We'll go to columns. And then we'll add a column. And we'll call this column inventory. So this is how many of the items that we have in stock. And so here, this is going to be an integer. And I think it makes sense for in our application to have a value for our inventory. We shouldn't leave it null. So I'm going to set it to yes. And I want you guys to see what happens when we hit save. Because the big issue is, right, this column doesn't exist at the moment. And so all of these items were created before there was an inventory column that was created. However, this column has a not null value, but it doesn't have a default value. Right? We gave is_sale a default value, so Postgres was smart enough to go into all of these pre-existing items and give it a value of false. Well, what's going to happen with the inventory? I didn't give it a default value, so let's see what happens. If I hit save, it throws an error. It says column inventory of relation products contains null value. So it's basically saying all of these products that you had before don't have a value for inventory. So at this point, you have a couple of different options. You could delete all of the previous products if you wanted to. And since this is a development environment, that's not a big deal. If you're in a production environment, that could lead to issues. Obviously, you don't want to delete your production data. So we could just give it a default value like we did before. And so I can just go back into, whoops, not there. We want to select this little button, go into constraints, and we'll say the default value is, let's say there's going to be 0 items. So let's hit save. And once again, I'm just going to open this up. I still don't know how to refresh it. I know there has to be a way. I can't find it, so it's okay. We could just open up this again, and then we can just delete these. I don't want too many of these. And I don't know why it's got squished up like that. But because we provided a default value, it got all values of 0. And so now if I create a brand new item, and I'll call this one, this will be a pencil sharpener. We'll give a price of $4. Is sale, I'll set to be true. Set to true. And then if we don't provide an inventory, right, it's going to get that default value of 0. All right, so I think we've almost wrapped up our schema for our products table. However, I want to add one more thing, and this is something that's pretty common. Anytime you create an entry within almost any other table, you usually want some sort of timestamp, right? So when did we add this product? When did this user create his account? When did this user create this post, right? So anything that we add into our database or in our application, it is generally best practice to store when that item was created, because you never know when you need to know that information. So let's create another column and let's see how we can work with timestamps. So I'm going to right click on products as usual, go to properties, and then under columns, we're going to add in a new column. And we'll call this column created at. And then here we have to select something that represents time. So what I recommend you guys do is just go to the documentation and then look at date time types. So there's a couple of different ones, but what we're going to do is timestamp with time zone. So we got timestamp without time zone and then timestamp with time zone. We've got just the date and then we've got just the time, but I want the date, time, and the time zone. So that's the most detailed. So I'm just going to search for timestamp. And we want timestamp with time zone. All right, and we obviously want this field always filled in. However, I don't want to have Fast API be responsible for creating the timestamp. I want Postgres to automatically create the timestamp for when the entry was created. So I want to be able to just create a product, and then as soon as it gets added to our database, Postgres will just fill it in with whatever that current time is. So how do we do that? Well, we can go into this right here. So let's configure this, add a constraint. And then here, all we have to do is for the default value, I want you to just write now. So what this is going to do is the default value for any product that gets added, it's going to run this specific command on the CLI. So this command just grabs what is the current time. Pretty simple, right? Now, I think it's pretty straightforward. What time is it now, right? And so this will set the default value. So if I hit save at this point, all right, since we had all of these other items that were created previously before there's a timestamp, what it's going to do is it's going to set the created at time to whatever time it is now, which technically that's not accurate because that's not when they were added, but these were created before we were smart enough to actually have a timestamp. So if we refresh this, so I'm just going to do a view edit all rows again. Right, you can see that they've all been given the same timestamp of whatever that current time was. And now if we add in a new item, and I'll add in, how about a keyboard? We'll give this a price of 28. Is sale, we can just leave that empty. How many in our inventory? We'll give it 50. And then we'll leave this blank. And so let's see if it automatically fills in what is the current time. And it should be later than this time, obviously. So we'll hit save. And so if we just double check, yep, we can see that this is about a minute later. And so now we've successfully added the created at timestamp.